Welcome to this session. This session will start with examples on integration by parts. So we have 4 problems for us to discuss. So the first problem is to integrate x cos of x dx. Second one is x squared cos x dx. Third one is x e raised power x. And fourth one is x power 3 e raised power x dx. So let's discuss the problem. So solution. A, we have integral x cos of x dx. So remember the integration by parts formula is integral of u dv is equals to uv minus integral of v du. So you have to choose u and v from the integrand so that now you are able to apply the formula. But as we said in the introductory part, you have to choose your u and dv wisely so that dv will be easier to integrate and u will be easier to differentiate. And because integration problem is much harder than differentiation problem comparatively, then the dv chosen should be a function that you can easily integrate without having problems. So here we'll say, let u to be this x, and when you let this u to be x, then the remaining stuff becomes dv, and dv to be cosine of x dx. Now from dv you get v, from u you get du. So this means du will be dx, and this one, integrating both sides, integral of dv equals to integral of cosine of x dx. V will give us integrating cos function, you get positive sine function. So we have our u, we have our v, we have our du, we have our dv. So therefore, integral of u dv equals to uv minus integral of v du. So integral of x cosine of x dx will be uv, u is x, v sine x, minus integral v du. So v is this, du is dx. And you see integral of a sine function can easily be obtained. So this will be x sine of x, and then integral of sine is minus cos. So minus minus is plus. So cosine of x, and then you add constant of integration. So therefore the integral of x cosine of x dx is x sine x plus cos of x plus c. Part B is the integral of x squared cos of x dx. Now, in a problem, you can apply integration by parts more than once. So here we say solution, let, because remember the formula is u dv is uv minus integral of v du. So let u be x squared, and dv, once we have fixed this, then the remaining stuff becomes dv cos x dx. So this means du, differentiate this one, you get 2x dx. And then this means integrating dv, integrate cos of x dx. So v will be integrating cos function, you get sine function. So we'll have integral x squared cos x dx will be uv. U is this, so x squared. V is sine x, and then minus v du. So we have integral, v is this du, so we'll have 2x sine x dx, which can be written as x squared sine x minus, we factor out 2, x sine x dx. So let's call this one I, the integral of interest. So we see we have this other part here. So integral of x sine x dx. This also requires us to apply integration by parts. So we let u to be x and dv to be sine x dx. This means that du will be dx and v will be the integral of this. Integrating sine function, you get negative cos function. So integral of x sine of x dx will be uv. So we have minus x cosine of x minus v du. So minus v du. So minus minus will be plus. So I'll say this one, cosine of x du is dx. And you see this one is the same as minus x cosine of x plus integrating cos, you get sine x. Now the constant of integration will add at the last point when we fix this value into I. So therefore I will be x squared sine x minus 2 into this value minus x cos of x plus sine of x. And then here we add the constant of integration. So that will give us x squared sine of x now plus 2x cos of x minus 2 sine of x plus c. So therefore, the integral of x squared cos x dx is given by this function. So this is the solution. And then part C, we are to integrate x e raised power x dx. Now, you let u to be x and du to be e raised power x dx, dv to be e raised power x dx. Remember, the formula is u dv equals to uv minus integral of v du. So du will be dx and v is the integral of e raised power x dx. Integrating e raised power x, you get e raised power x. So integral x e raised power x dx will be uv is x e raised power x minus v du. So e raised power x at du is dx. That will give us x e raised power x. Integrating this part, you'll also just get e raised power x and then plus the constant of integration. So therefore, this gives us the solution to our problem. And lastly, integral of x power 3, x power 3 e raised power x dx. Now we let solution, let u to be x power 3 and dv to be e raised power x dx. So du will be 3x squared dx, and v is the integral of e raised power x dx. This would give you e raised power x. So integral of x power 3 e raised power x dx will be uv minus integral of v du. So uv will be x power 3 e raised power x minus v times du. This so will have integral of 3x squared e raised power x dx. So in that next step, factor out 3. So we'll have, let me call this one I, is x power 3 e raised power x minus 3 integral of x squared e raised power x dx. So we also have to use integration by parts to carry out this integral. So we have x squared e raised power x dx. So let u to be x squared and the v to be e raised power x dx. So that means du will be 2x dx, and here v, integral of e raised power x dx, which is e raised power x. So we'll write integral of x squared e raised power x dx equals to uv, so x squared e raised power x minus v du. So v du, so we'll have 2x e raised power x dx. So which will be x squared e raised power x minus, I factor out 2 integral of x e raised power x dx. Now let me replace this one in in the integral I. So I will be x power 3 e raised power x, then 3 times this integral, and we have this one, so it'll be minus 3x squared e raised power x, and then this minus times this minus would be plus, so 3 times 2 is 6 integral of x e raised power x dx. So we also still have to use integration by parts to carry out this integral. So integral of x e raised power x dx. So we let u to be x and the v to be e raised power x dx. So this means the u will be dx, and here means the integral of e raised power x dx will be e raised power x. So then now, replacing this into the integration by parts formula, integral of x e raised power x dx, uv, so x times e raised power x minus v du, e raised power x du is dx. So which will give us x e raised power x minus e raised power x, and then we'll add a constant of integration finally. So therefore, this integral I will be x power 3 e power x minus 3 x squared e power x plus 6 into x e raised power x minus e raised power x. So I've just replaced this one into this part, but then I add the constant of integration. So when I simplify, I'll get the integral I x power 3 e raised power x dx is x power 3 e raised power x minus 3 x squared e raised power x plus 6 x e raised power x minus 6 e raised power x plus c. So that's what I get. And you see every term here has an e raised power x. So I can write it as x power 3 minus 3x squared plus 6x minus 6. And then I multiply by e raised power x. And then I say plus the constant of integration, c. So that's how we solve those 4 problems. Thank you.